All right, so let's get into loans, and we've already talked about loans a little bit. We're going to talk a lot more about them more systematically. So before I do anything about loans, there's a very important quote in the book on page 183. It really has nothing to do with anything in the course necessarily. It's just good advice. So I want to share that good advice with all of you. Before borrowing money from a friend, decide which you need most. So something to think about, you know. Anyway, okay, so we're going to talk about amortized loans, and that's just a fancy term for a normal loan, basically loans that we've been dealing with throughout this course. Okay, and by what that means really is that it's a loan that it's basically an equation of value. Okay, I get some cash in, and I have to pay that back. That's literally it. You get cash in, you have to pay some of that back. Okay, you have to pay all of it back, not some of it. Okay, and yeah, as I mentioned, all regular loans and without, unless I state otherwise, all loans in this course are going to be an equation of value. You get money, you have to pay that money back, and you have to pay that money back time value. Okay, so to make sure we're all on the same page here, let's do an example. You take out a loan L at 5% effective annual interest, and pay back the loan with 10 yearly payments of $1,000 and another 10 yearly payments of $2,000. If payments are at the end of each year, then how much is L? Okay. So I'll put this solution up on Blackboard in a PDF. Let's just go over it. Okay, so the problem is you take out a loan of L, and you pay it back in 20 installments. This is 20 here. At the end of each year, for the first 10 years, it's $1,000. And at the end of each year, for the next 10 years, it's $2,000. How much is L? Okay, so all we're going to do is set up an equation of value. Make this a little bigger. Okay. So, yeah, hopefully there's no issues, concerns about this timeline. You just, this is your cash in. You need L right now. This is your cash out, what you're paying the loan back with. Okay, so, right, your cash in equals cash out time value. That's what an equation of value is. Okay, so we break this up into two annuities, essentially. The first one is just, 0 to 10. So present value is 1,810.05. Payments are at the end of each year. And we're taking a present value because, the loan is made at t equals 0. So we want all these payments time value to t equals 0. And that's the same thing as saying we're just taking the present value of all these payments. Okay. So the present value at t equals 10 of the 2,000 payments is 2,810.05, because that way, as we've done dozens of times, the 2,000 payments are at the end of each year. So at the end of the 11th year is t equals 11. Right, so we do the 11th year to the 20th year. Right. So at t equals 0, this is the present value of the 2,000 payments, but it has to get discounted by 10 years. So we have to go back to t equals 0. So, because we don't really want the present value of the 2,000 payments at t equals 10, we want it at t equals 0. So, yeah, we discount it by 10 years. Same interest rate, 5%. So you get these two values, So L is 17,202.68. All right. And also find the accumulated value of these payments, both time valued and not. Okay, so if you want the time valued accumulated value, basically the same thing, just we're taking accumulated value instead of present value. Okay. So right. So the accumulated value at t equals 10 of 1,000 payments is 1,000 S10.05, but that sits in the, that theoretically sits in an account and earns 5% interest for another 10 years. So the value of the accumulated value of these 1,000 payments accrue 10 years of interest. So it's 1,000 S10.05 times 1.05 to the 10th. And then the 2,000 payments don't accrue any interest after we accumulate them at t equals 20. So it's 2,000 S10.05. Okay. So again, we're going at the end of the 10th year to the end of the 20th year. So at the end of the 20th year, the 2,000 payments accrue to 2,000 S10.05. And that's going to be 46,643.85. You could have also just simply taken this number here, and this accrues 20 years of interest at 5% interest, and check that that is true. Because we're saying at t equals 0, the value of all these payments is 17,202.68. So at t equals 20, the value of all these payments has to be the value of this at t equals 20. And the value of this is 17,202.68 times 1.05 to the 20th at t equals 20. So easier, quicker way to do it, but just kind of quick review of getting the accumulated value of an annuity. Okay, and kind of a more practical question: what's the non-time valued accumulated value of all your payments? Well, there's not a whole hell of a lot to that. You have 10 payments of 1,000, 10 payments of 2,000, so that's 30,000. Okay, so due to interest, you take out roughly $17,000 loan, 17,202.68, and you have to pay back 30,000 of it non-time valued. Okay. So if there's any questions on that problem, do let me know. And again, I will put this I'll put this PDF on Blackboard. So if you want to go through this while just looking at the PowerPoint, and I'll put the PowerPoint too on Blackboard. But yeah, or if you just want to look at the PDF while I'm kind of going through all this, then yeah, that's fine. Okay, so in general, just kind of restating what we've talked about in the past and what I just mentioned a moment ago. So if I have a loan and it's repaid by n periodic payments, K1, K2 through Kn at the end of each period, then for all loans we'll deal with, by definition of an amortized loan, the value of the loan is the present value of all these payments. And so it's K1 new, K2 new squared, all the way to Kn new n. Okay. And if you want to see a time diagram, here's the cash in. Okay. The cash in equals sum of the cash out, time valued. You discount this by 1 period, 2 periods, n period, As usual, nu is 1 over 1 plus j. J is effective per period interest. I used green for L and red for, green for L because that's the cash in, and I used red for the payments because that's what you're paying. Okay? Yeah, and unfortunately, if you're looking at the stock market right now, you've probably seen a lot of red, like you see a lot of red in this slide, but anyway. Okay, so let's get a little deeper into loans. Particularly, it's pretty practically important to know at the end of each period how much the loan is worth. First of all, if you have extra money and you just want to pay off your loan, it's good to know how much you got to pay. Like if you take a 30-year loan out and you get a raise 10 years from when you make the loan, you save 10 more years of interest, you might want to just pay off the loan at the end of the 20 years with your savings. How much do you have to pay? Okay. And this is called the outstanding balance. And another reason you might want to know, well, what your outstanding balance is, well, if you want to take out another loan, in general, just you can use home equity as collateral. I'm sure you've heard people say, buy a house and start building equity. That's exactly what I mean by home equity. And that is the home value minus the outstanding balance. It's how much, maybe not exactly how much you can sell the house for, but, practically speaking, roughly how much you can sell the house for minus how much you owe on your mortgage. It's a very practical way to, describe kind of the value, the real value of your house, essentially, home equity. All right. And the way the mechanics of these loans, and the mechanics of all loans is basically you first pay off interest, and then what is left goes to principal. And principal is basically your outstanding balance. And so you need to know how much interest, it's good to know how much interest you're paying each period. One reason is that interest is tax deductible. As a matter of practicality, with the standard deduction so high, it's a lot of times not worthwhile to itemize your deductions. So take a tax deduction for interest, state and local taxes. But if it is worthwhile, you absolutely can. Even if it's not worthwhile, you can take interest paid as a tax deduction. Okay, so it's useful to know how much interest you pay at the end of each period. All right, so a table with all this practical information is called an amortization table. Now, I should mention I have no idea where the word amortization came from. It's a very bizarre word, but it's not like I came up with the word myself. And as I mentioned, often outstanding balance is called principal. It means the same thing. All right, so instead of diving into formulas, let's do an example. I have a loan of $27, $23, $25 is to be repaid by 3 back-to-back yearly payments of $1,000 at the end of each year. Interest is 5%. Just create an amortization table. So I'm going to run through this with you guys. Again, because rather than just plug and chug into formulas, which is not very, I'm not going to say it's not useful, but it's very important to understand what's going on. It's very practical to understand how your loan payments work, your student loan payments work, how your home mortgage works. Okay, so here's the table. All right. And if you're curious, I made this table with LaTeX. Everything, all the symbols here, like PowerPoints are made by LaTeX. But if you're curious what on earth that means, just let me know. Okay, so let's just commonsensically fill in this table. So, sorry. First of all, I take out a 27, 23, 25-cent loan. Okay, that's how much I owe right now. Now, theoretically, if I hit the lottery, I could pay this back right now. Most mortgage and loan companies assume you're not going to pay the loan back immediately, because why the hell would you take the loan out in the first place if you can just immediately pay it back? So theoretically, for most loans, without a pre-penalty payment, you could just immediately pay it back. And if you did, well, you took out 27, 23, and 25 cents, you would pay 27, 23, and 25 cents. Okay, so your first payment is $1,000. Actually, all three of the payments are $1,000. So practically speaking, what is your interest? Well, it's just how much you owe times 0.05. It's 5% interest. So that's 136.16. Okay, so you first pay off interest. So you take the 1,000, subtract 136.16, because you're taking 136.16 and paying off the interest. What you have left is what you are using to chip away at your principal. You have 863.84 left, and you're using that to chip away at your principal. Again, outstanding balance is the same thing as principal. They're synonymous. Okay. So out of this amount that you owe, you've paid back 863.84 after interest. So right now, at the end of t equals 1, at the end of the first year, this is you're paying back every year in this loan. This is how much your loan is worth. So again, if you won the lottery or you got an inheritance, whatever, you get a bonus at work. If you had the money at the end of the first year, this is how much you can pay the loan back. This is how much the loan is worth right now, and this is how much you would pay to be absolved of all your debts. Okay, so the second payment, 1,000. So the interest earned in the second year, well, again, there's really no subtlety here. Commonsensical calculation. At the end of the first year, you owe 1859.41. That accrues 1 year of interest at the end of the second year. And so times 0.05, that's going to be 92.97. You got to pay that back before you start chipping away at your principal. So you have 907.03, 1,000 minus interest to put towards your principal. Okay, so you subtract this off. You use the 907.03 to chip away at your principal. So now you owe 952.38 at the end of the second year. Okay, and that's how much, if you had the money, you could pay the loan off at the end of the second year with. All right, same thing. So 952.38 times 0.05, 47.62. That's how much interest accrues in the third year. Again, 952.38 accrues a year of interest. Okay. So first pay off the interest, and what you have left, you can use towards the outstanding balance, and you'll notice that, well, you have after paying interest, you have 952.38 to put towards your outstanding balance, which is also 952.38. So at the end of the third year, you owe 0. You don't owe anything, which it better be the case, because I said a loan is to be repaid by 3 back-to-back yearly payments at the end of each year. So, something would be wrong if you had an outstanding balance of something other than 0. Now, you could have, often you're going to get an outstanding balance at the end of the loan at, 2 cents, 3 cents, something like that. That's just due to rounding. But if you don't get pretty damn close to zero at the end of the loan, you did something wrong. Okay. So let's get to some notation. So if you have any questions on this table, let me know. You really shouldn't, because this is very practical stuff. All right, well, I mean, we're not going to end there, of course. So let's introduce some notation. And this is the book's notation. I think it's fairly standard actuarial notation. Excuse me. These lectures are kind of hurting my throat a little bit, but that's all right. All right, so, right. OBT is the outstanding balance at the end of T years. And again, practically, that's the value of the loan at the end of T years. That's how much you can pay at the end of T years to get rid of your debt. And OB0 is the loan amount. It is how much the loan is worth at the beginning of the loan, and that's what we call L. That's how much you take out. PRT is the principal repaid in the teeth year, and IT is the interest paid in the teeth year. Sorry. And as I mentioned, if you have an end period loan, meaning the loan is paid off after end periods, then you better have OBN is 0, or practically speaking, very close to 0. Theoretically, it's always going to be 0, but due to rounding, you could have it a couple cents, 10 cents, maybe even something much, much, much smaller in scale than anything you're dealing with in the loan. Okay, so let's just think about what we did for to get the formulas in our table. So the first year's interest, well, the value of the loan, L, accrues 1 period of interest. So it's L times J. J is decimal, so it was 0.05 in the previous example. PR1 was, well, basically you take how much your first loan payment is, you first pay off interest, the rest goes to principal. All you pay, you're just paying principal. And sorry, you're just paying interest first, then principal. It's all just those two pieces. Okay. So not much to say there. And well, just plugging in for I1, OB0 times J. And OB1 is just, well, how much the loan was worth. You're paid off interest, so it's just how much the loan was worth in the previous period minus what you're paying, what you have to pay principal. So it's the previous period's outstanding balance minus what you have left to pay principal. And in general, the formulas are as follows. IT is just the value of the loan in the previous years. The value of the previous loan, the value of the loan at the end of the previous year times J. That value, the value of the loan at the end of the previous year accrues 1 period of interest. Interest rate is J. So that's the amount of interest earned in the teeth year. PRT is just the KT minus IT. The amount of principal you pay in the teeth year is just, well, the amount of your loan payment, knocking off interest first. What you have left goes towards principal. And again, just plugging in for IT. And, outstanding balance at the end of the teeth year. You take the outstanding balance at the end of the previous year, and you use the rest of your, the principal repaid to chip away at that. All right. So if there's any questions there, just let me know. They're a little bit abstract, but if you really think about it, this is exactly abstractly what we were doing, very concretely in our amortization table. Okay, and I should mention, when t equals 0, this formula doesn't make a whole hell of a lot of sense, because what's OB minus 1? Outstanding balance at t equals minus 1. We don't do that really in this course. Doesn't make much sense. So by definition, OB0 is just the loan amount. All right, so let's do the same problem, but using the formulas. And when I say create an amortization table, you don't literally have to write it in like table format. You can just give me all the information that would be in the table. Okay, so let's do that. So what we're given is the loan value is 27, 23, and 25 cents. J is 0.05, 5% interest, and all the payments are 1,000. So, right, we're just plugging and chugging. The interest earned in the first year, or the interest you have to pay in the first year, OB0 times J, 136.16. The principal you pay in the first year, 1,000 minus 136.16, 863.84. The amount that goes towards the outstanding balance in the first year, it's your outstanding balance. The outstanding balance at the end of the first year is going to be 27.23 minus principal. The principal repaid 1859.41. So again, sorry, this is the outstanding balance at the end of the first year. How much the loan is worth at the end of the first year. All right. So the interest earned in the second year, your previous outstanding balance times 0.05. The amount that goes towards the outstanding balance in the second year, just 1,000 minus 92.97. Your second loan payment minus knocking off interest first, minus your interest first, 907.03. And at the end of the second year, the value of the loan, this is how much the loan was previously worth. So you took care of interest. Now you use the principal repaid to chip away at the outstanding balance, 952.38, et cetera, et cetera. And just like before, just like it better be, you get maybe not necessarily 0 here. You do get 0, but you get, you get something very, very close to 0.